focused on the topic design of rotary file. Desired canal shape, what a radiograph portray, can be attained with any set of instruments, provided they are used properly. But what matters is how effectively we can attain the shape. That is another matter. Capabilities of a file made up of same material are entirely dependent on the design. Even the incidence of the fracture rotary varies according to the type of instrument, the brand, the size, the taper, and the cross section. So it's very important to discuss the components of the file. So what actually rotary file is? It consisting of the flutes, the land, the cutting edges, the helix angle. We'll discuss each one by one. Let's take up what are flutes and land. Flute of a file is a groove in the working surface used to collect. This is the flute. It's a groove on the working surface used to collect the soft tissue and the dentinal chips removed from the wall of the canal. The sharpness, the effectiveness, it depends upon the width, depth, and the configuration of the flutes. So what is the land? Land is the surface that projects axially from the center as far as the cutting edge. This is a land that projects from the center as far as the cutting edge between the flutes is called as land or marginal width. Now in some of the files, they have reduced this land area we call as the relief. They make it regressive. So what are the purpose of the land? Why land is given in between the flutes? Land reduces the transportation of the canal. It supports the cutting edges. It reduces the screwing in forces, screwing in tendency of the file into the canal, decrease the propagation of the cracks, and limits the depth of the cut into the dentin wall. Now the land need not to be very wide. If the land is very wide, it is more in contact with the root canal wall. If it is more in contact, there is more of force of abrasion. There is more, we require more torque to prepare a canal. We don't want more torque to be applied during preparation at will because it may lead to increase in fracture propagation or increase in torsional failure. So these land should be regressive, it should be less. The wide land can be useful in small diameter files which add rigidity and enable the file to negotiate curvatures. Now if we say, like if a file is efficient or it has a very sharp cutting edges, it's not say that it is aggressive. If a file is efficient, it has a greater cutting ability, it requires less time, it requires less torque, pressure to accomplish the canal preparation. So if we are applying less torque, pressure, and time, more likely the file fracture can be prevented. So once a file is rotated, so it should be keep in mind, if a file is very efficient with the sharp cutting edges, so if a file is rotated one time in one position, canal can be enlarged to the file diameter, and to avoid transportation, it should not remain in that position for long if one's canal is enlarged. Otherwise, it will lead to transportation of the canal. So now, what is the cross section of the file? Do it really matters? Yeah, the mechanical performance of the endodontic file is mainly governed by its geometric configuration. Like what is the cross section, how it is made up of, whether it's triangle, it's rectangular, it's parallelogram. So to have that mechanical performance, we need to see what's the cross section of the file. And the cross section not only affects the risk of separation, but it also leads to the generation of different amount of stresses on both root canal wall and stresses on the root canal wall during shaping. So there is a difference. What is the cross section area and what is the core area? So what is the core of the file? Is the cylindrical center part of the file having circumference bordered, outlined by the depth of the flutes. This is the core. The flexibility and the resistance to torsion is partially determined by the core diameter. It do affects the torsional resistance and it will affect the flexibility of the file. More the core, the less the flexible, but more the torsional resistance. And the relative diameter of the core compared to the file total diameter It may vary along the working surface. Why it vary? In order to change the flexibility and the resistance to torsion. If you want to have a more of flexible in the apical region, then we'll reduce this core area, and we'll have, if we want the coronal part, we want our file to be more rigid, we'll increase this core area and the cross section area. Now, what is the cross section area total? Cross section area of the instrument area is determined by the number of parameters. Like, it depends on the size of the file, the taper, the design. Increase cross section area, we can increase it by increasing the size of the file, the taper. And if it is more cross section area, it means it has more of torsional resistance. And it can be reduced by increasing the depth of the flute. We can decrease the cross section area by increasing the depth of the flutes. Like many of the files now, they are being provided by various cross section along the working surface. Like one shape from Micromega, they have variable cross section. They have a triangular cross section at the apical region, S-shaped cross section at the coronal part. Like if we consider like this is a hero shaped gold cross section, it is a large cross section area. This file is very strong. It's able to bear large torsion forces. This is the triangular cross section of a file of a flexor from Mothers International. They have a triangular cross section. So according to some studies, it has been said that if you want to increase the torsional resistance, it's better to increase the cross section area irrespective of increasing the total core area. If the core is more, because the file is more gonna be more rigid. So now, why some of the files now, they have been provided with an offset cross section. What is this offset cross section? If a file offset is having a parallelogram cross section, but all the 4 points do not contact at one time, only 2 points contact at a time, that is an offset cross section. So why it has been provided? During the rotary preparation, the contact between the instrument and the dentine, it creates internal stress in the instrument and the reaction torque in the root dentine. So we feel, when we are preparing a canal, at times we feel a screwing in forces because of these internal stresses. What is screwing in forces? It is a tactile sensation that the rotary file is being pulled into the canal in the apical direction. If we don't resist it, it will go beyond the apical foramen. It will lead to over-preparation of the apical foramen. It will weaken the root. There is an apical root cracks. It may lead to tapered lock. It get tapered lock, and more torsional stresses will be generated and may increase the risk of instrument fracture. So we need to reduce the screwing in forces. One of the steps by which we can reduce the screwing in forces, like we discussed earlier, either by providing the land, but what land is creating, if we have more of a land area, it is more of for abrasional forces. So second step, what they have done, the manufacturers, like they provide an offset cross section. Although they have a parallelogram cross section, they have a large cross section area, file may be strong, but only 2 points are contacted at a time. So due to which there is a less of the contact between the canal wall and the file, less of the stresses are generated, and this offset design thus will reduce the contact and reduce the torsional stresses. Like we have for the example, like this wave 1 bolt, they have a parallelogram cross section, but only 2 points they contact at one time to the canal wall. This is ProTaper next, which has a swaggering type of motion because of this offset cross section area. Now, what is rake angle, cutting angle, and helix angle? By definition, if the file is sectioned perpendicular to the long axis, rake angle is formed between the leading edge or when the file blade meet the canal wall at obtuse angle or an acute angle. That is called as rake angle. This is when it is like section perpendicular, it is called as rake angle. Rake angle can be positive or negative. What we are concerned, if a file manufacturer says like they have a positive rake angle, means it is cutting. If it is a negative rake angle, means it has scraping motion. So most of the files, they are provided with now positive rake angle, because positive rake angle means they are more efficient in cutting. Like example, like Hero Shaper Gold, they have a positive rake angle. Flexor from Mothers International, they have positive rake angle. But if you have a negative rake angle, if you have an acute angle, then it is more of scraping motion is there. So if a file has more of negative rake angle, it scrape along the root canal wall. There's more of torsional, more of frictional forces generated. So for that, we provide the positive rake angle. But if a file is sectioned perpendicular to the cutting edge, the angle that is formed between the leading edge and the surface to be cut is called as cutting angle. And what is the helix angle? Helix angle is the angle of the cutting edge to the long axis of the file. Angle that the cutting edge makes with the long axis of a file is called an helix angle, and this serves to auger the debris which is collected in the fluids from the canal. So this helix angle, it helps to remove the debris from the canal. So most of the files, they have variable helix angle. So however, this helix angle is changed with the pitch of the file. Now what is the pitch? We need to understand the pitch of the file. Pitch is the distance between a point on the leading edge and corresponding point on the adjacent leading edge, or in simple form we say number of spirals per unit length. Number of spirals per unit length is called a pitch. More the spirals, lesser is the pitch. Pitch is the distance between the spirals. If we have more of spiral, less is the distance between the spiral, and more is the helix angle. And most of the files have variable pitch, one that changes along the working surface. Like number of spirals will change along the surface. If we have a variable pitch, means number of spirals are changing along the working surface. Or they may have variable helical angle, either by the change of the pitch, or they can have a variable helix angle by changing the FLUTE angle. If the FLUTE angle is changing, the helix angle will change. Now most of, like if a diameter of the file, it increases from file tip towards the handle, FLUTE will become more deeper and resulting in a core taper that is different from external taper. Like Hero Shaper Gold is now, they're provided with a change of helix angle from tip to the shank, as with the changing of taper of the file, and the pitch increases according to taper. So if we have an increased taper from the tip towards the coronal part, the coronal part will be more rigid because it is more of taper, but we don't want that coronal part to be more rigid. So we increase the flute's depth, we increase the pitch also, and will increase the depth of the grooves and make it more flexible. And the most of the file, but today they are manufactured by asymmetrical cross section. If we have a file of asymmetrical cross section, means they have change in the radius. They may have small radius somewhere, they may have large radius somewhere. So if we have asymmetrical, we are provided more of obtuse angle, means more of positive rake angle. So the file with asymmetrical cross section will generally have a positive rake angle, means they are more cutting efficient. Now discuss the taper. What is the taper? We say like it is a 4% taper, 6% taper. It is the amount of the file diameter. It increases each along the working surface from tip towards the handle. There are two types of the shaft design depending upon the taper. Either it may be a progressive taper or it may be a constant taper file design. Like Wave 1 Gold for example, is provided with a progressive taper. The taper is continuously decreasing from tip towards the shaft. And according to studies, it has been said that instrument with a progressive taper can prepare canal more quickly than a constant taper. But there is an advantage and disadvantages to both. So one thing should be keep in mind, if we have an early curvature in a coronal or the middle 1/3 of the root canal, it is more likely to fracture compared to apical curvature. So if we have an early curvature in the root canal and the coronal part, because the file here is more rigid, it is more thick, more diameter. So here, if we have a more curvature at that point of the file, we need to see our file need to be more flexible. Now the tip of the file. Tip of the file can be cutting tip, non-cutting tip, or it can be partially active tip. Cutting tip, it will have the ability to enter the narrow calcified canal, but if it go beyond the apical foramen, it will lead to formation of an elliptical tear. So we don't want to have a cutting tip all time. But according in the Cohen, it has been given most of our retreatment files, they are provided with a cutting tip. We need a cutting tip in retreatment files. And in the most of the normal rotary files nowadays, they are provided with a partially active tip or semi-active guiding tip that will allow the file to move on the canal smoothly. Like in Wave 1 Gold, we have a partially active tip. So at the end, it matters like how well a file performs while following a specific technique. It should not be the measure of effectiveness. Rather, how well the capabilities of the file can address the requirement of the anatomy should be the measure of its usefulness. And we can use different instruments for preparation and technique. And this technique where you use more than one type of instrument is called as hybrid technique. Thank you.